welcome all. Thank you for coming. I think it's a very timely kind of talk, so I hope there's going to be a lot of questions and a lot of interest coming from the. So this is the mission of the CIBSE Energy Performance Group, to improve the energy performance of buildings, as you might expect, provide an expert Q&A forum covering key aspects of energy performance, of which this is a part, enable networking opportunities, and to respond to and support the implementation of emerging legislation. So what we have for you today is we have 4 speakers, I had to count them, and they're going to be talking about fuel poverty in a variety of different ways. We quickly introduce them now. So we have Billy Cliffen from Turner and Townsend. He's going to be talking about some of the kind of challenges in the UK and with the retrofit approach, and some of the kind of schemes that are available as a methodology for retrofit or to help funding of retrofit. So Energy Sprong and the Social Housing Decarbonisation Fund, which is part of administering at Turner and Townsend. We have George Munson then from Leeds City Council, who's going to talk specifically about the Leeds Pipes programme for district heating that he's involved in. Then we have Brogan Watkins from Hoare. He's going to be speaking mostly about the experience of domestic retrofits in Wales and actually retrofitting some smaller properties to very high levels of energy efficiency. And then we've got Ann Pasquale, who's going to be talking about some of the problems and some on the ground stories from actually looking at her own house, and the implication of PAS. And Lisa's from RetrofitWorks. We're talking about fuel poverty, which is, I think, a great one for the EPG. It touches all kinds of different people's work. So the definition of fuel poverty for the UK government is actually the acronyms LILEE, which are low income, low energy efficiency. Sorry, I temporarily forgot the acronym. Is how the UK government defines it. So that's someone who's both got an EPC of below D on the house, and their income levels. If you take their total income, remove the amount that they're spending on heat, if that will put them into the poverty category, then, and their house is under D, then they're classed as being in fuel poverty in the UK. So it's got 3 main components: household income, energy requirements of the house, and the energy prices. And as you probably know, there's a lot of people in the UK right now who are struggling on all 3 of those things. So it's a very variable picture. There's huge amounts of change. There's huge amounts of challenge in the UK with our older housing stock, and particularly the amount of Victorian housing stock we have. And so hopefully we've got speakers from right across the country that can represent some of those challenges. So yeah, so first we're going to be going to hand over to George from, and he's going to talk a little bit about what they've been doing in Leeds.
Great, thanks, Jake.
Thanks, George.
So yeah, thanks for inviting me along here today. I'm George Munson. I'm a project manager in the Sustainable Energy and Air Quality team in Leeds. Just for a little bit of background on Leeds, it's the 2nd largest authority in England after Birmingham, and we've got 3 key priorities as a council: inclusive growth, health and well-being, and climate emergency. Next slide, please. So the climate emergency was declared in Leeds in 2019, and it underpins everything that we do as a council now. When it was declared, the chief exec and the leader made it very clear to all the chief officers and heads of service that regardless of which part of the council they sat in, climate emergency was part of their day job. It had to be integrated into children's services, asset management, planning, highways, the full range of work that we do as a council. And I think critically, when we declared climate emergency, it was something that was picked up across the city as a whole. So it's not just a council-led issue. In Leeds, there's something called the Leeds Climate Commission, which was established by the University of Leeds and a whole host of public, private and third sector organisations, who are really coalition of the willing, people who are actively working to reduce their own direct and indirect emissions and then bring others along on the journey. But there was life before climate emergency. Next slide, please. And we've had a long-term focus in Leeds on carbon reduction and fuel poverty. Leeds has 320,000 homes. We own about 55,000 of those ourselves. There's about 80,000 Victorian terraced properties. and we're unique in having around about 20,000 Victorian back-to-back terraces, so properties like this on the screen. We've been working really hard to try and create the right solutions for those properties, because they are often in some of those deprived parts of the city with disrepair and very, very poor thermal efficiency. So we've done cross-tenure, area-based initiatives, and have really led the way in that sort of area over the last few years. Just a shot here showing a kind of before and after. I could talk all day on this, but I'll leave it for now because I've been asked to focus on district heating. So next slide, please. In terms of, that's a picture missing. That's very strange. In terms of what we're doing, we've built an we've built a district heating network in Leeds, which kicked off in 2019 and it's kicked off construction in 2017, kicked off operations in 2019, which is linked to our energy from waste plant that you can see on the right hand side of the screen there. It's critical that it's got this low carbon source of energy. We've got 33 megawatts of backup boilers embedded in the network, but we are really only using those for backup when the energy from waste plant goes down for planned or unplanned maintenance. But we really have been kind of leading the way. It's the largest district heating network outside of London, currently under construction. So it's growing rapidly. If we have a look at the next slide, you can see a map of the extent of the network. So the picture of the energy from waste plant is down at the bottom right. It's in cross green. So when we were procuring our energy from waste plant, we were very clear that it had to be within the urban fabric of the city, and it had to be something that was designed to be district heating enabled in day one. We didn't want it to be district heating enabled forever, never producing any heat to go alongside the electricity production. So we took the opportunity as a council during the procurement to work very closely with Veolia to make it to have all the right preconditions within the contract, so it's clear commercially how a network could be developed. So we're in a great place then in 2017 to take the decision as a council to make our own investment in it and kick off a network. So it started with the network that runs up to the flats in the top of the screen. So we connected around 2,000 council flats to the network as our phase one. It's very deliberate. We attracted some ERDF funding to change those from the underloved storage heaters within the flats into good quality, lower cost, lower carbon wet central heating systems. That went very successfully. We then bid for some funding to build a second phase into the city centre, which completed last year. We've now connected 5 major civic buildings to it and are actively connecting other commercial buildings onto it. We've now got ambitious growth plans. So the dotted lines you can see there are current bid with HNIP to further extend the network to either strategic locations in the city or identified loads. If we look at the next slide, it's critical for our network that we get about 95% of our energy from the energy from waste plants. We all are very aware of the volatility in the energy markets at the moment. So the graph top right shows the current market position, wholesale market position for gas and electricity. It's been about a 300% increase over the last year. Left-hand side is just the price cap that's applied to domestic energy customers for their gas and electricity bills, around about a 200% increase since about 2020, 2021, with a forecast that will increase by maybe another £1,000 by this autumn. But RPI has only increased by 10% over that period. We know we're going through a cost of living crisis. 10% across all goods is a very, very big impact. But because we're buying the vast majority of our heat from an energy from waste plant, which we have indexed primarily to RPI, we're in a very strong position to provide good value to our customers. So just to wrap up, we look at the one more slide. We've got both commercial and domestic customers on the network. When we were initially running pitching to our customers, it was very clear that customers wanted to see district heating being pegged to their current utility costs, to the gas index. So the graph top left just shows how the gas index for 3 different sized customers has actually changed over the last 5 years or so, and it's really only over the last 3 to 6 months that we're beginning to see a spike in that. So we're finding now that customers are very keen to try to steer away from the gas index where they can. So we're offering a mix of RPI and a BASE index. So it just kind of blends the risk both for them and for us. But for our residents, and these are 3 of the first tower blocks that we connected up to the network, which also benefited from external wall insulation as part of the work. We actually pegged it to RPI. So whereas the majority of people in Leeds are experiencing cost increases of 200 to 300%, our residents connected to district heating are only experiencing about a 10% cost increase. So it's been a fantastic tool in the fight against fuel poverty. We know that a lot of these areas were very, still are very highly deprived. So if we're able to at least provide a bit of basic need at an affordable rate, then we know that we're improving well-being for a large chunk of our population. And I'll hand back to Jake now. I'm very happy to take a whole range of questions at the end.
Yeah, so my name is Brogan Watkins, and I'm a sustainability consultant working for Hoare, and going to be talking today about Bragl, which is a pioneer in energy positive social housing development located in Bryn in South Wales. Next slide, please. Just a bit of background on Hoare. So Hoare are a team of engineers, designers, and technical specialists. We have over 150 years of history, and Hoare has around about 11 offices throughout the UK and a growing presence internationally. We work with about a quarter of the FTSE 100 listed companies, and we provide a wide range of services to deliver sustainable, safe, healthy, and successful buildings. And we recently announced the sort of framework going forward that's all about balancing the priorities of people and planet, which can often be slightly conflicting. Next slide, please. So Bragl is a social housing development comprising 2 one-bed apartments, 10 two-bed houses, and 2 four-bed houses located in Bryn in South Wales. And the project was funded by the Innovative Housing Programme, which was launched in February 2017. And it's initially a 3-year programme with a budget of £90 million, with a target to build 1,000 affordable homes to really accelerate all of the learning and the understanding within the industry around low carbon technologies and sustainable housing. The funding essentially pays for the innovative elements of the design, so looking at heat pumps, solar panels, batteries, and all of the supported projects must be independently performance monitored, where Hoare's building performance team comes in. Next slide, please. The concept is based on the Salsa House. So the Salsa House is the smart operation for a low carbon energy region. And it was built in Bryn in 2015 as a collaboration between the Welsh School of Architecture and some local energy modelling firms. And you can see there it's featured in The Guardian as Britain's first energy positive house. It had an energy export to import ratio of 1.75, so that means it's actually giving out 1.7 times energy that it's using. And it was all focusing in on smart controls around solar energy to ensure that you can export more energy than you import. Next slide, please. So the technology behind this concept is all focused around passive design principles, which essentially means making as much use of solar as possible, making sure it's well insulated, there's really airtight so that heat you're generating doesn't escape easily. It uses MVHRs, which is mechanical ventilation with heat recovery, so it passes over the warm air inside the home over the air that's coming in to make use of that existing energy. It has an exhaust air heat pump, which works on the same principle that air source heat pumps do. that lots of people are familiar with now, except it doesn't have an external unit. So the condenser is found inside in a piece of ductwork where the air that is extracted from the property is passed over the condenser to extract that thermal energy, and you get efficiencies of around about 300%. The exhaust air heat pump will have an output of around about 2 kilowatts, and usually homes are between sort of 5 and 7 kilowatts. So for these to work in properties, you're going to need really well insulated buildings with really good air tightness. It also had built-in integrated solar panels on the roof, a battery to store some of the energy, LED lighting, optimized controls, so using pieces of equipment when the cost of energy was lowest, and green tariffs, which we'll go on to later. The specification is here. You can see that the building fabric is really good. It beats all of the Part L compliance, which is key. It's not quite at what you would need to achieve passive house, but it's somewhere in between. And then you can see all of the details of the equipment that went in as well. The key one is the 400-watt electric tower rail, which once we've got the post-occupancy data, you'll see why the electric tower rail has quite a big impact on the overall annual energy consumption. We have existing data for the cost for social housing within Wales, and the guidance is that should be £1,800 per metre squared. Bryn Bragl came in at £2,436 per metre squared, which is an increase of 35% for this pilot scheme. Speaking to the contractors and subcontractors, those additional costs basically attributed to the improved building fabric, the building integrated solar panels, and the battery storage. But this cost difference is anticipated to decrease sort of proportionally to the number of new technologies and new projects that we have in South Wales. And it'll be fascinating as the economy of scale is introduced, and as these developments get larger, how close that Bryn Bragl cost can get to the Welsh Government cost guidance. Next slide, please. What we've basically got plotted here is the annual energy use intensity divided into all the categories within the house for all of the different plots, and divided and then categorized by how many bedrooms they have, with the REBA targets, business as usual, 2025 target and 2030 target there to provide context. You can see that at the bottom of all of the bars, we've got heating, hot water, ventilation, and at the top we've got cooling, which are the traditional regulated loads. So through good design, you're able to be pretty precise in accurately anticipating what those figures are going to be. You can see then in the middle, the two lighter shades, we have plug sockets, so that's all the equipment, and then cooking, lighting, and towel rails. These are the ones which have huge variance from property to property. So you can see that this is far more dependent on individual occupant behaviour, whereas the regulated loads are fairly standardised throughout all of the plots. Despite these all performing quite well, none of them are at the 2030 target, and I believe there's 4 of the properties which are beneath the 2025 target, all of them beneath the business as usual target. We then have the energy balance equation. So you can see that the red is the energy imported, so that's taken from the grid. The grey is exported, so that's left over from the PV panels and storage that's sent back to the grid. And the green is the energy balance, so that's the remainder that you actually need and consume within the house. All of the plots which are below the x-axis with at 0 energy positive, so they're actually sending out more energy than they're consuming. And there's no clear trend here between the properties as you categorize them per bedroom. It's fairly sporadic, but we think the biggest indicator really of the performance and determination of whether it's energy positive or energy negative is really the unregulated load. So how people are using the plug sockets, the cooking, the towel rails, for example. We then have data on the costs. So essentially we've got a Tesla tariff. So the Tesla energy plan, that bar's gone shooting up off the screen, but the Tesla energy plan is an energy tariff specifically designed for homes with solar panels and Powerwall. So the Powerwall is the Tesla battery that's included in these property, and it offers 100% clean electricity and huge savings. So all of the green bars, which have negative numbers, correspond to the energy positive properties, actually mean that the consumers will receive that payment from Tesla for last year's energy bills. So they're actually receiving money back to alleviate the fuel poverty. The bar on the far left is the Wales fuel stress line, which is defined as 10% of the post-tax income it's spent on fuel bills, then you're in fuel stress. So that's at £2,300 per annum, roughly, based on the average salaries within Wales. So with the exception of plot 1, even the negative properties are spending on average less than 1% of the average post-tax income. So the social benefits of all of that are untold. And I'm delighted as well that the Welsh Government has since committed over £250 million towards 20,000 low-carbon homes to really establish Wales as a pioneer for scalable design solutions when it comes to energy-positive social housing. The Built Environment Global Summit report was hosted by REBA and, yeah, next slide, that's fine, was hosted by REBA and Architects Declare in October of last year. And it essentially identifies the best practice in built environment ahead of COP26. It's sort of formed part of a report which was ultimately presented to global leaders at COP26. And Bryn Bragl was identified as a best practice case study, and the report is available online if anybody wants to have a read of it. It's called the Built for the Environment report. Thank you very much.
Right, so I'm going to explain a bit about PAS 2035. So looking at the kind of standards at the moment for retrofitting to relieve fuel poverty. So my name's Lisa. I'm the technical lead at RetrofitWorks. We deliver a wide range of domestic retrofit across mostly the south east of England. And I've been heavily involved in PAS 2035, partly in the very early stages of development. I developed the original risk assessment for Greater London Authority. And then also in the implementation, rollout, and sort of initial testing of PAS 2035. So we've been sort of shaking this out the last 2 years to try and get it as functional as humanly possible. A bit about the process. So the PAS is a bit unique in that it specifies a sort of project management process as to what things need to be done, who needs to do what, in order for a retrofit project to deliver its intended outcomes. So it lays out a series of steps, starting with the really basic things like setting the intended outcomes of the project. So when we look at things like fuel poverty in a lot of cases, if you're looking at trying to reduce someone's spend on energy, ultimately very few retrofits can achieve that in a fuel poverty scenario, because very often those people are underspending so radically on their fuel that we really can't drive down the cost much farther for them. What we can do is make what they're spending give them a better quality of environment. That's usually the outcome that we tend to see. So we'd be looking at different metrics for how we measure whether or not we've achieved the goals. In terms of both potentially spending, but more importantly, whether it's alleviating the stress of that person being able to switch on their heating, whether they're able to heat their property more frequently to a higher temperature, whether they're able to heat more of their property. So quite often we find that people in fuel poverty are only heating one room at a time. Very often it's only the children's bedroom or something like that. So we need to be setting the intended outcomes in the very early stage of the project. And then that whole process that comes after that, we're looking at a detailed assessment, a retrofit coordinator overseeing the entire project, a detailed risk assessment based on the intended measures. Risk paths A, B, and C are defined in the standard. And effectively, the idea behind them is that a risk path A project is usually relatively simple and straightforward and requires kind of minimal oversight to go ahead. Whereas a Path C project in many cases is a very advanced retrofit. It's a whole house approach, or it's on a property that has a particularly high risk of unintended consequences. So something like a high rise, a traditionally built building in a conservation area, that kind of thing. So the risk path is then defined, and then that sets out the project management and the oversight requirements for the dwelling. The dwelling assessments for PAS 2035 require a ventilation assessment. So this is something that's never really been done comprehensively in retrofit before. But we need to be looking at very detailed kind of balance of what exactly the ventilation is going to be doing after we retrofit a home. And ultimately, once all of this is implemented, installed, it has to be installed according to PAS 2030-2019. We're going to be doing monitoring and evaluation to make sure it has actually achieved those intended outcomes, and making sure that we haven't accidentally caused any unintended consequences. So there's a number of things in practice, which is important to kind of be aware of. So we have different roles defined in PAS 2035. So assessor, coordinator, designer, installer, and evaluator. And these roles in the different risk paths take on different levels of oversight over one another, different levels of coordination. And in some cases, a person can be multiple roles at the same time. So a really good example would be like an MCS installer installing a heat pump. They are both the designer and the installer. Likewise, cavity wall insulation, both the designer and the installer. EWI, also both the designer and the installer. And ultimately that simplifies things a bit from a liability perspective, that if something fails, there's a sort of basically a single person to blame for it. And the coordinator is there to basically oversee and make sure everything's done properly according to the right standards, that they're using the correct materials, that they're putting things together in the correct sequence, that they're all being sealed up and finished correctly. And I mean, we've seen things like a particularly good one quite recently was we needed to put a fan in a bathroom that just had one of those kind of standard brick vents as an intake. We were going to use the same hole as an extract. And we said, you can use that hole, just seal it up, put a proper duct through, and you can put the fan through that hole so you don't have to drill a new hole through the wall. And we went to site and found they had taken the grill off. They'd literally just set the fan inside the hole. And we're just like, no. So we have to be able to kind of oversee some of these things that you would think are quite simple in practice, but end up being quite difficult to implement when we're dealing with the level of installation that we're used to seeing in domestic retrofit. So the PAS specifies a fabric first approach to retrofit. They need to be looking at maximizing air tightness, using high levels of insulation where appropriate, optimizing solar gain, using ventilation appropriately, using thermal mass appropriately, and most importantly, resolving thermal bridges such that we don't end up with condensation and mold risks on the inside of the property, which can then cause air quality problems and potential health issues. It is supposed to be a whole house approach. Now, this is where we've been running into a number of problems with the existing funding that we've got in the UK that's at the moment quite prevalent. So the LAD schemes up to Eco 3, Eco 4 is a slightly different animal. It's, I think, about to come into effect quite quickly. So basically, up until now, we've been trying to implement this with schemes which had relatively low levels of funding, where it's actually quite difficult to get a whole house retrofit. I mean, if you're talking £8,000 to £10,000 of funding for a house, we're going to get a few windows and a front door out of that. We're not going to get a whole envelope. We're not going to get a whole new ventilation system. So we're struggling a bit with a mismatch between the standard and what it requires us to do in terms of look at a whole house retrofit, do fabric first, and what the funding is actually allowing us to do. Because we do need to be doing all of these things at the same time, ideally, to get a coordinated solution and to get everything working correctly together. So it's correctly sized, it is properly insulated, it is made airtight in the right way. So at the moment, we've got a big disjoint between what funding will allow us to do and what we actually need to do in properties. And that's making us struggle quite a bit in practice. One of the key documents that we're required to do, so these are all the various documents that we need to do under PAS 2035, but one of the really important ones is the ventilation assessment. And that's the one that we've actually in practice been struggling with the most. And somewhat luckily, this was initially put in PAS 2035 several years ago, out of the fact that the original Part F, which was published up until December of this past year, so that when you retrofit dwellings, you should make the ventilation no worse than the existing condition, which the fact of the matter is most homes actually don't have adequate ventilation to begin with. They rely on infiltration. And so a detailed ventilation specification was put into PAS 2035, knowing that in a few years, Part F was going to be updated. And then we would have a proper kind of legal backstop to how we'd address ventilation in retrofit properties. So the new Part F has come out as of December of this past year. It comes into force in about a month's time. And it has some unique features to it, which is I would say very, very well done. Which is that it requires that all retrofits require some improvement to the ventilation in the form of extract fans in the wet rooms. So basically, if you're working in a house that doesn't have any ventilation at all, that just has a recirc fan in the kitchen and just opening windows in the bathroom, that won't fly any more under building regs. It has to be upgraded. The fans have to be put in. That gives us a really nice, good, solid legal backstop so that we can't have people opting out of fans, which at the moment is what's happening. People are quite reluctant to accept them. So we will have fans kind of in a more mandated position in about a month's time. And one of the issues that we kind of were quite sympathetic to when we work with residents is, you know, if their funding is only getting them a door and a couple of windows, the last thing that they want is for us to punch 2 or 3 holes in their walls to put fans through if they didn't already have them. Because it's definitely not lost on them that if we punch 2 holes in the kitchen and the bathroom to put fans through, but we've only replaced their front door and nothing else, that we've actually just made their home more leaky than it was to begin with. And that's a real problem with the fact that the funding is what it is at the moment. Is basically it's not covering enough of a retrofit that it then makes the ventilation upgrades worthwhile. So that is a bit of a struggle at the moment. And even under the new Part F, that's still going to be a problem. So we do need to look at expanding funding to make it more holistic and let us address the whole property. More major retrofits under the new Part F require improvements to air intakes that replace the loss of advantageous infiltration that come from improving building fabric. So basically, we're going to have to start putting in trickle vents and various other things as we make the building more airtight. Again, this is a lot easier when you do the whole fabric in one go. It differentiates minor and major measures to allow more minor improvements to go ahead without requiring us to upgrade things like retrofitting trickle vents into existing windows. So this is something that's come about as problematic in the practical implementation of PAS 2035 that requires us to put trickle vents in all instances. Is it effectively, if someone got their windows replaced 2 years ago and we're going in now replacing their door, under PAS 2035, we have to then go retrofit trickle vents into the windows if they didn't already have them. And the problem there is that once we drill holes in those windows, we've just written off that customer's warranty on their windows. So we've had a lot of pragmatic problems with implementing the standard as it's currently phrased versus what we know to be in the best interest of the homeowner. So hopefully the new Part F will give us a bit more leeway in how we kind of address this. The other thing that it does do, which is quite important, is it allows for expert design. And this is where I think CIBSE really should be coming into its own here. Where we've got some grey areas in what is defined as the scope of the retrofit as to how much improvement to the background ventilation and whatnot we actually realistically need. It allows for someone with a correct background to go and say, actually, in this house, I've tested the air tightness and it's XYZ, you know, air changes per hour at either 4 Pascal or 50 Pascal. I say we only need XYZ kind of intakes. We only need such and such fans. It lets someone who's appropriately qualified then basically set out the ventilation strategy and put their name behind it and say, right, that is correct according to me, the engineer. At the moment, the existing Part F, the previous version, and PAS 2035, neither of them allowed that. So this is where I really would like to see CIBSE stepping up and kind of taking that role. And that's me.
Thank you. Yeah, hi everyone. My name is Billy Cliffen. I'm a senior consultant at Turner & Townsend. And we at Turner & Townsend, we have a sustainability team, and within that I sit in the housing team. And our main support that we provide to the social landlord sector is helping them retrofit their housing stock, largely focusing on achieving decarbonisation targets, but also grappling with fuel poverty and trying to mitigate that risk. So I'll be talking today about two key programs that we are delivering. The first one is the Retrofit Accelerator Homes program. That's a GLA funded program. And the second one is the Social Housing Retrofit Accelerator program that we're delivering with BEIS. And both are retrofit-led programs that take different approaches and work with the sector in different ways to mitigate fuel poverty. So we can go to the next slide. So the brief to me was, what are some of the long-term solutions to fuel poverty? And I think we don't really need to sell retrofit as a solution in terms of, targeting the leaky and old housing stock that we have in the UK, and taking, when I talk about retrofit, I mean really taking a fabric-led approach to reduce the heating demand in properties, and also preparing them for low carbon heat and power. So retrofit as a solution is clearly the best way to mitigate the risk of fuel poverty and protect residents from rising energy costs. But really what I want to talk about is actually the challenges around delivering retrofit at scale. Working at upskilling the sector, both on the social landlord side, but also working and developing the supply chain, and really looking at how that can happen, how we can go from sort of the pilot project world of retrofit to rollout of delivery and actually helping residents across the country that are really struggling. And also, it's not just a technical focus in delivering these programs. We really encourage delivery programs to work with residents, make them and put them at the heart of that journey, so they understand what's happening to the property and they have a say in the measures that are being chosen, and they can therefore that sort of mitigates the risk of them not understanding the new retrofit program that's been delivered. So we can go to the next slide. So the first program is the Retrofit Accelerator Homes program, which is a GLA and ERDF funded support program. And really this is about two things. It's demonstrating that the Energiesprong, which is a Dutch model that's been brought over here, which is Dutch for Energy Leap, and it's focused on delivering retrofit for the whole house, so delivering net zero carbon in one hit. And these are some pictures of Energiesprong, not from London, but from across the country. So the Retrofit Accelerator Homes program is demonstrating that Energiesprong can be delivered in London, even considering its aged and diverse housing stock. And also through that, focusing on laying the foundations for delivering a sustainable market scale up. So bringing the supply chain together, and we're developing an innovation partnership framework through this process, so that in the future, other social landlords can come to the framework and work with approved suppliers who have demonstrated that they can deliver Energiesprong in London. So we can go to the next slide. So I'm not going to do a really deep dive into what Energiesprong is, but I thought I'd cover some of it. It's essentially a whole house retrofit project that provides a guaranteed monthly cost and comfort package for residents. So after the delivery of Energiesprong, residents pay an energy service plan, which is equivalent to their previous energy bill, and that energy service plan repays the capex cost essentially for the landlord. Because retrofit has struggled in the past with, the landlord invests all the money, but they don't see a return, if you like, from that investment. So they've struggled to develop a funding mechanism. So Energiesprong really targets that by providing a sort of long-term performance in the energy consumption post-delivery. And that helps to kind of provide this fixed monthly cost that can repay the capital works. So what the Retrofit Accelerator Homes program is not just doing, it's delivering the Energiesprong, it's creating a market for it. So it's working with landlords to help them develop the business case. It's working with the supply chain to develop modular offsite solutions that will really help to industrialize and scale up and commit to volume that we'll need to see to deliver more of these similar schemes. And that volume helps to bring the costs down in the long term. So in 2018, the average sort of Energiesprong cost for a whole house in the UK was around £80,000, and the target is to bring that down to £40,000 by 2025. we go to the next slide. To bring that to life a little bit, these are some of the proposals that go into an energy sprung project, and what this is the building is essentially wrapped up. The whole building fabric is wrapped up with off-site panels that are manufactured by the supplier, and sort of no stone is left unturned really. There is the whole building is wrapped up. There's a whole house sort of fabric strategy alongside a ventilation strategy, which Lisa talked about in the last slide. And this really significantly brings the heating demand down, and the target is about 40 kilowatt hours per meter squared per annum for the heating demand. And also there's low carbon heat comes in with an air source heat pump. Although the energy sprung model is actually technology agnostic, so it doesn't have to be necessarily a heat pump, but that's a typical solution that we see. And this one here has an MVHR solution to ensure that whilst the whole house has been sort of plugged up and is really airtight, that fresh air is delivered to the property afterwards. Next slide, please. And this is one of the energy sprung projects that we've delivered with the Retrofit Accelerator Homes programme in London. So you can see the difference there from top to bottom. Next slide, please. So I'm going to talk about the second programme now that Turner and Townsend are delivering, which differs quite a lot to energy sprung. The principle is the same. It's focused on retrofit, but rather than a whole house programme, this is the Social Housing Decarbonisation Fund, which is a 3.8 billion funded programme to be delivered over 10 years. So that's funding from government, promised in the Conservative manifesto. So the SHDF programme focuses on much more of a phased approach to retrofit, because there is clearly a funding challenge both on the landlord side and the government side. And the whole house retrofit isn't always feasible, it's not always possible, and it's certainly not always affordable. So some landlords are mixing their portfolio approach to retrofit, doing whole house retrofit where they can, but isn't a deep one hit, but in other properties doing this phased approach. And that's what the SHDF programme focuses on. So it targets properties with EPCs lower than D, so E's, F's and G's. And it looks to bring them up to EPC C and to achieve a heat demand target of 90 kilowatt hours per meter squared. So it's largely looking at external wall insulation, loft insulation, new windows, this kind of the fabric first approach. But also what Turner and Townsend deliver is the Social Housing Retrofit Accelerator Programme. And that provides free funded support to social landlords. Because government recognised that the sector was struggling maybe to develop projects and therefore to put in quality bids to access funding, we provide support to social landlords to help them sort of scope out their projects, understand their data, go through the procurement process, and then move towards sort of procuring past 2035 roles as well, like Lisa talked about. So we give free funded support to do that, and really sort of gear up and move the sector towards delivering that retrofit at scale. So that is my last slide. Thank you for listening.
I'd like to invite all the kind of speakers to turn their cameras back on, if you like, join our kind of virtual panel now. And I thought I'd just ask a couple of general questions to the group as a way to kind of kick us off. So first off, and this may be a little unfair to anyone that hasn't done a lot of quite dull reading over the last couple of days, but I was wondering, with the Queen's speech, and there's a lot of new announcements coming out over the last couple of days around planning. Particularly, I'm thinking with the work that we're trying to plan, what was most interesting to me was this this idea about street votes and setting separate kind of planning rules for different streets, which may allow, you know, a little more flexibility in terms of retrofit or overcladding or new stories or those types of things to buildings. I was just wondering if there was anything anyone saw in the Queen's speech that pointed to, you know, potentially some kind of change in what we're talking about here. Should I direct that, or should I take that as a not very much? I appreciate there wasn't a lot of detail in what was released so far. Okay, all right. So about a wider question of, so my background is from more architectural design side than many of you. And what we're finding at work is that, I'm working for a council housing developer in Newham, and we're finding that actually the 60s and 70s blocks are in some way more valuable to us, because as we're seeing now in some of those energy sprung examples, you have a nice flat facade and it isn't listed and people won't object. You can quite easily and cheaply insulate these properties. Whereas, and George, I think you might have something to say about this, where you have a lot of Victorian solid wall properties like we do in Newham and you do in Leeds. Actually, the planning system and this new push towards beauty, which is again reconfirmed in the Queen's speech, that can be something that's actually really hindering us. I don't know if you've got any kind of interesting examples of that, or comments on how we get around those issues.
Yeah, sure. I'm very happy to kick off on that. Completely agree. 60s, 70s are dead easy if you do them right. If you approach them in the right way, you can make a pretty terrible building look much better. So the slide I showed of the 3 tower blocks, they needed extensive concrete repairs. We just took the opportunity to do those concrete repairs and then overclad and actually make the whole thing look significantly better. The other slide I showed on Holbeck, the Victorian terrace property, I think we struggle to find many people who argued that the kind of before was particularly beautiful. We have a lot of Victorian terrace properties in very, very significantly deprived parts of the city, with issues of disrepair, leaking roofs, plants growing out of the walls. Some don't even have damp courses. So we're struggling. We have to tackle the disrepair before we can even get any insulation works to be done. The frustration we have is more about the funding than the technical solutions and the issues with kind of beauty. In the points Lisa making absolutely right about the lack of coordinated funding for significant works. The examples we gave cost us about 30k per property to tackle disrepair and then do a full enveloping job. Typically, we can get 8 to 10k from external grant funds, get about 25% from the landlords, even in these most deprived areas. But then we have to find ways to plug the rest of that gap from kind of here, there, and everywhere. And then I think it's worth commenting as well on PAS that the 30k was kind of pre-PAS 2035 measures. We've always done them as part of large schemes where we've worked with good quality installers, and we know that there's no issues with the properties following the works. But we have to now follow PAS, which adds 5 to 8k onto the properties and is likely to leave us with whole parts of the city which just have nothing done to them, rather than having a very good solution. So we're in a real pickle at the moment.
Yeah.
I would add to that.
Yeah, I was just
there's
going to say, because we're running a little late, so I hope everyone's okay with staying just another 5 minutes to finish this conversation. But please, yeah, you don't feel any obligation to stay. But yeah, thanks, Lisa. And then Brogan, could we bring you in afterwards as well and talk a bit about, obviously, Wales has a lot of this ex-industrial kind of housing stock, but at the same time. So thanks, Lisa.
I would say one thing that we've run into with the implementation of PAS on solid wall properties, which has been a huge problem, has been the fact that at the moment there's only 2 approved internal wall insulation systems under Trustmark. So they need to have a specific guarantee in order to be put on to basically be paid for and signed off under Trustmark. At the moment, those 2, in my personal opinion, neither of which are really suitable for solid masonry walls. So they're a combination of vapor closed materials or systems that have a plastic vapor barrier in them. And ideally with solid wall properties, what we want with those masonry properties is IWI, which allows full breathability all the way to the inside of the property. So I live in a 1901 Glaswegian tenement with 800 mil thick solid stone walls, and I used calcium silicate and wood fiber. It's all the way vapor open all the way to the inside where I've done it, and that is ideally the sort of solutions we want. We need those sorts of materials available to us in order to address these properties when we can't really do stuff on the outside because of the visual impact. And at the moment, we've got a big problem that none of those have the correct approvals under Trustmark. They don't have the correct insurance-backed guarantees, and we can't use them at the moment under the PAS technically. So that's been one that we've been bashing our heads with, the insulation assurance, the IAA. I don't know exactly what it stands for, but them and SWIGA trying to get the right systems with the right guarantees in place so that we can use those in the places that we need them. And that's something that we have flagged to BAYS and a number of other organizations, but that's a huge hurdle at the moment.
Yeah, I agree. I think the issues really are around ventilation and humidity, aren't they? It's far more complex than just approving products. So, yeah, Brogan, if you want to come in on.
Yeah, so I mean, my experience is all around the technologies really, as opposed to the actual fabric of these buildings. So within South Wales, we know that we have huge amount of houses that are squeezed into the valleys throughout the 20th century, and space at an absolute premium. So the government's heat and building strategy was published in October, I think, and it basically outlined their policy moving forward to be focusing on heat pumps to provide heat in buildings, particularly for a residential scale. It really dismissed hydrogen, and it basically means that we need to come up with some sort of strategy to get heat pumps into these small houses with limited external space. In addition to that, across Wales, you've got one of the highest wind generations in Europe. So that coupled together, you've got two problems. You've got heat pumps with a large electrical load, and you've got wind turbines producing unpredictable levels of renewable power. There's a big challenge there to try and match those two up, but that looks as though it'll be the kind of key problem going forward to net zero.
Actually, one just small issue that we come across in our properties in Newham, East London. So we have a lot of these kind of properties, a lot of back-to-backs, and we'd like to be able to just put the heat pumps in the front. It's obviously a lot easier, but the planning laws kind of want us to crane us over the back and put it in the small garden. It just adds a huge amount of cost to the system. I think there's a lot of these things which make more complex. Billy, I don't know if you want to comment on that and how maybe some of the larger ways that bigger bodies are trying to solve these problems.
Yeah, I mean, I used to work for a social housing organisation called Octavia, and we struggled with understanding what the low carbon heat solution would be for a lot of these terrace properties. And apart from kind of waiting maybe for sort of low carbon district heat networks to come down the back streets of London, which is, you know, if feasible and affordable, that would have been good, but it felt like a long way away. My approach always would have, if I was in charge, I would really back a sort of high performance Enefit type approach to retrofit and try and mitigate the need as much as possible for M&E, well, heating anyway. Particularly from a maintenance perspective as well. You know, landlords spend millions of pounds maintaining this kit. It's hard enough getting into properties, let alone the cost. So, but Enefit, you know, again, a fantastic solution, but hard to fund it with the lack of funding around at the moment. So this is why I think people end up taking this sort of middle, they get stuck and they go down the middle path and they go for a lower spec retrofit ambition, because it meets the kind of challenge of lack of funding, you know, difficult supply chain issues as well.
Yeah, if I could just jump in there. Like, what do you think? I mean, because I've always thought it's a little odd that we have a lot of funding to get all the properties up to a C, whereas C's not that great. You know, like what I'm trying to push in our council is that, you know, if you're going to take a D or an E, why don't we make them A's or B's? You know, a minimum. Why don't we push them to the zero? You know, do the fabric first approach, go straight. What is our 2030, which is when we're meant to hit zero carbon as a council? Shouldn't we be jumping straight to A's rather than C's? And is there an issue if we're funding retrofits up to a C?
Yeah, I mean, I think there's a second issue as well, using SAP and EPC as a long-term net zero target as well. I don't think it's really fit for purpose, and that's where like Letty have done a lot of good work, sort of moving away from that and encouraging heat demand. Yeah, you could direct the funding to just focus on worst first and bring them all the way up to an A, but I think the reality of that is quite tough because you've got pepper potting, so you might only deal with a few properties in a street. It doesn't help you to lift everyone up out of fuel poverty. It might focus you on a few properties only. So I think the stepped approach is a bit more pragmatic, given the funding constraints.
Yeah, thank you. Great. I think we're just heading for 1:10 now, so we should probably start to wrap things up. But I think I'll just give everyone each a chance to kind of do a kind of final closing statement, if you will. Sorry, I didn't ask you to prepare that ahead of time, but I don't know what would you say is the most important kind of challenge that we have to tackle around fuel poverty? If you just do a kind of quick one sentence, one short statement. Who should I go to? Billy, can we go to you first? Since you're just talking.
Yeah, I think two. I'll give you two. I think remembering the importance of resident engagement, and not just taking, the technology is important, but really involving the residents, because they will impact the long-term, have an impact on long-term outcomes, and they need to be involved early on. And I also think working addressing some of the challenges around the supply chain, thinking about how they can be increased capacity and capability to deliver this work.
Yeah, brilliant. Maybe Lisa, I'll bring you in there. You were mentioning supply chain issues as well.
Yeah, so I'd say one of the biggest challenges is how we can basically make fabric upgrades accessible and easily deployable. So again, that's a bit of a skills thing. I ended up doing all the internal wall insulation myself in my property, because I brought in plasters and said, right, this is how it has to be done. It has to be fully adhered. You can't do dot and dab. You can't do this. And they all just refused to quote for it. They said, that's not how we do things. And the fact of the matter, it had to be done that way to make it effective insulation. And they just never encountered that before. So I do think there's a huge skills gap, even just the basics of teaching people how to put insulation on correctly.
Yeah, absolutely. Brogan.
Two things. So I think protecting against the volatility of the energy global market. So that can be done in a number of ways by providing low carbon technologies is probably the key one, I think, as we move forward. But then also controls and when we're using different fuels. So you'll see that as we start to retrofit buildings and have higher spec fabric, the regulated loads of the heating, cooling, ventilation, lighting, which reduced and becomes a smaller percentage of the overall energy consumption. You can see then that the equipment and the unregulated load will actually have a larger impact. So if we can start to use them when the cost is lower, maybe through the night with more sophisticated controls, I think that can have a really big impact moving forward. It also has a really big benefit on the carbon as well, with dynamic carbon factors.
Thank you for those contributions. I think that's really great. I think there's clearly a lot of work to do there, but it's great to see how much progress we are making with with PAS 2035, with Energy Sprung, with all these various, and Retrofit that we mentioned briefly at the end there. There are solutions out there, I think, but I think we just need a lot more case studies, isn't it? We've just got to work out as many ways as possible and really try to up the funding, I guess, is one of the big things. Is we need something like 30 to 40 grand per property, not 10 grand per property. But yeah, thank you all for presenting. Thanks everyone for coming who was there. I hope you got some of your questions answered there, and consider joining us, the group, or just joining one of our other presentations again. And we'll have a whole series of these power hours planned, and we'll have a whole series of carbon bites coming up, just talking about interesting issues as well. So yeah, thank you again, and we'll have a great rest of your day.